Welcome to another CyberLab video. The narration was generated using text-to-speech for efficiency. This video is based on a hypothetical scenario where a company grants external access to its web server, so a web pro can help them make a better portal. They allow password-only logins for SSH, a weak configuration. We then walk through how an attacker who has captured that password might log in, steal password files, and crack the files to learn other users' passwords. It's best if you follow along in the lab instructions as you go along. They include helpful explanatory notes. We will start by opening a terminal window as administrator and running a script that creates and starts the VMs we need. Start typing terminal in the search box. When you see the right app icon, click on Run as administrator. Use the provided administrator credentials so you can run protected commands on the Windows VM. Navigate to the folder that contains the needed PowerShell scripts. Type cd space, c:// and press enter. Then type cd space bis and press the tab key. Then type POW and press tab again. Then press enter. Start typing the name of the script startsc and press tab. It may delay a bit, but it should bring up the name of the script as shown. Press enter to run. The script creates and starts up several virtual machines in Hyper-V. It also makes some adjustments to the Hyper-V network so that the web server is accessible from the Windows machine. You need to press Enter 3 times in the script window to confirm that you want to reconfigure the Windows internal networking. Once it is all started up, you can think of the Windows VM as the device used by the webmaster. The router will direct SSH and HTTP messages to the ecom web server. Click on the machine name in the Hyper-V window to see the 3 new VMs. In Step 2, we will use the nmap utility to see what ports are open to the outside world on the virtual router's address. First, we type TERM in the search box to open a new terminal window. We could use the one from before, but we will follow leading practice and not run as administrator this time. At the command prompt, type nmap space 172.17.1.2 and press enter. That asks nmap to scan that address for open ports. It takes a moment, but the response will show in the terminal window. The only identifiable entry points into the network are shown as port 22 and port 80. It shows that SSH over TCP is closed on port 22 and that HTTP is open on port 80 via TCP. In Step 3, we provision 2 webmaster accounts in Linux on the web server. Navigate to the Hyper-V window and right-click to connect to the ecom server. It was started by the script. This allows you to interact with it. Choose a resolution setting that works for your system. The default may or may not work well for you. Log in using the provided web server administrator username and password. The user is isadmin01. The password is shown. You may want to remember the password. It is one of 2 that you will use several times during the lab. It may take a half a minute to open. Open a terminal window using the icon as shown. The prompt indicates who is logged in, isadmin01, and the machine name, which is ecom. The commands to create a user are listed in the instructions. They use superuserdo or sudo in front because these are restricted functions. The first is sudo adduser webmaster. When you press enter, it will ask for a password for this new user. Use the one shown here. You will need to type it a number of times during the exercise. You can press enter for the other information the system asks for. It's not important for this exercise. The next command, sudo usermod-ag sudo webmaster, adds the webmaster to a group which is allowed to give superuser commands. The syntax is explained in the provided instructions, or look it up for yourself. Press enter. The lab machines will suggest updates now and again. Don't worry about them. These machines are reset after each lab session. The next command makes a directory in the webmaster's home folder. We will use this folder later as part of the process of stealing the Linux password files. Press enter once you have it typed in. This next command adds a second webmaster account with a terrible password, ABC123. You will see later that this password is easily cracked. As before, skip over the other user info by pressing enter several times. In our scenario, the webmaster needs to access the server from outside the network. Good practices could protect this login a number of ways, including dual authentication, passkey access, and allowing access only from devices inside the network. But actually, lots of systems are configured weakly for a variety of reasons. Navigate back to the terminal window on the Windows machine. Remember, in our scenario, this is like working from a device in another building, city, or country. In the video, the console still shows the results of our nmap query. It showed SSH as being closed. Go back to the ecom VM. Now we are going to act as the administrator and enable external SSH access. Type the command sudo service SSH status and press enter. It shows the inactive but loaded SSH service. Once you see the results, press Ctrl-C to exit the status listing. Now start the SSH service with the command as shown. Using the up arrow brings the last command to the prompt. Then we can edit. In this case, we pressed up twice to bring back the status command we used before. Using that feature can save some time. The SSH service is now active as shown in green. Ctrl-C exits the listing. Now let's verify that SSH is running by rerunning our nmap command on the Windows VM. Remember that VM is outside our organization's network. Navigate to the Windows Terminal console. Rerun the nmap command. Up arrow works here too. As expected, the SSH service is now open and accessible from outside our network. Next, we will go back to the ECM server as the IS administrator. We will allow access to the web server using password-only authentication. The basic configuration for SSH blocks such access. But maybe we haven't got dual authentication set up yet, and we need this work done right away. These kinds of things happen in real organizations. Click back into the terminal window on the web server. If you closed it, you may need to open it again. And if you delayed between steps, you may have to log in again. You know the admin pass. Use the command cd /etc/ssh and press enter to navigate to the folder with the SSH configuration files. etc holds lots configuration folders. Then type ls and press enter to see a listing of the files in that folder. We are going to change the details in sshd_config to allow password-only authentication for SSH. Using the sudo edit command opens a designated text editor and provisions super user rights so that protected files like sshd_config can be changed. Scroll down to line 57 in the config file. It instructs that when SSH loads, it is to not allow password-only authentication. With this setting in place, some other form of credentials are needed. Usually that means dual authentication or use of stored and recognized encryption keys. Put a hashtag at the beginning of the line to comment it out this configuration instruction. That means that password-only authentication is no longer forbidden. Click Save at the top of the screen and X to exit. The SSH service needs to be restarted so that SSH will reread the config file. The command shown here restarts SSH, and because of the change we made, password-only SSH login is now enabled. Now we will pretend we are a bad actor coming in from outside the network. We somehow stole the webmaster's password, probably by compromising their machine or phishing. Perhaps the most confusing part of this lab is figuring out where you are. It can be challenging in any case. But in this exercise, we are already using nested virtualization and remote access. As you go through the following steps, try to keep track of where you are. All of the remaining steps are done in terminal windows that run on the Windows VM. This is as if they are done by some hacker in another country. We will use two terminal windows. One is a simple console window. The second is a remote shell. You will know this shell because it will say Webmaster at ecom at the top. Commands in that window are passed to the ecom server for execution, and results are passed back to the Windows console for display. But we will also use the SCP secure copy command running directly on a terminal in the Windows VM to connect to ecom and transfer back our stolen files. It's a lot to keep track of. Navigate back to the Windows VM and use the Open Terminal window. If you closed it, you can open a new one. The SSH command invokes SSH, and the username and IP address specify which device to connect to. We are opening a remote shell. This will allow us to execute commands on the ecom server. We are going to make copies of its password files. SSH entails lots of possible security risks. Typing yes and pressing enter verifies that we realize we are connecting to a new and previously unidentified host. You may remember the webmaster's password. You set it up a few minutes ago. Type it in and press enter. The prompt and the terminal tab label now show that commands typed here will be executed on the remote ecom server. Password files, like the ones containing the 2 webmaster logins you created, are protected. They are stored in special folders that are hard to access and read writes are controlled. But because the attacker is using credentials with super user rights, they can evade these protections by making copies of the files and moving them to a less protected place on the server. 2 files are involved, shadow and passwd. These two commands copy the files from the protected /etc folder into a folder more directly under the webmaster's control. Depending on timing, you may need to use the webmaster's password to execute the commands. Also note, we used the up arrow to bring back the previous command and then changed one letter. Both files are needed to support logins and therefore to allow password cracking. The copied files are still protected. Attempts to copy them off to another computer would be blocked. These two chown commands take away that restriction by making Webmaster the owner of the files. Now that copyable copies have been made, the attacker will use Secure Copy, SCP, commands running on the Windows VM to request transfer of the files to the attacker's device. The last few commands were run in a remote shell that executes on the ecom server. The next step begins with opening a local shell. Click on the plus sign to open a local shell in a new tab on the terminal window. It takes a bit of typing to get these two commands right. Pay special attention to the colon in the middle. Depending on your setup, you may be able to copy the command from the instructions and paste it in. The SCP command includes the IP address of the server from which files are to be copied and the username used for access. Executing each command requires entry of the webmaster's password. You may notice that part of the command identifies the remote folder name, and the last part determines where the copies files will be stored. Now that the hacker has the files on their own device, password cracking begins. Usernames are readily available in the stolen files, but only encrypted versions of the passwords are stored. It can't read them, it has to guess them. The tool John the Ripper is publicly available. With just a few commands, John is instructed to begin guessing passwords and seeing if they are found in the files. John uses common passwords and common password patterns to try to make good password guesses quickly. Navigate to the folder that has the stolen files. cd space c:/bis_ files. This command uses a tool from John the Ripper to combine the passwd and shadow files into a single file we call crack.these. This next command is pretty long. Be careful to get the quotes and double quotes in the right place if you aren't able to copy and paste it in. This is needed to convert the binary encoding on the cracked file. This last command tells John to start guessing. The simple Webmaster 2 password, ABC123, is quickly guessed. These lab machines are not all that fast. It would take a while to guess the Webmaster or IS admin passwords, but it would get around to them eventually. Once it starts its work, you can press Enter to see what it's doing. For example, it will show which passwords it is guessing. After a few minutes, it shows that it cracked the password for Webmaster 2. If you are interested, you can explore on the internet to learn more about the details. The point is, the attacker has now successfully broken the e-com server's password file. Really strong passwords in the file may take a long time, perhaps years, to guess. But most users make bad passwords, and even good passwords can be guessed by fast computers.